right, I very quickly want to go over the introduction to 6.1.2. So a lot of times we think, okay, this is geometry stuff we're doing, so it's not related to algebra, but in reality, you do a lot of algebra to figure out some very simple geometric proofs or geometric things that we need to consider here. One that we're really going to talk about is how to get from the Pythagorean theorem, which is, an equation, right, to something called the distance formula, which is another equation. Again, both of which relate to the lengths of lines, specifically with right triangles. So we can use that theorem, and this is a whole bunch of notes and blah, 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 and explaining that kind of stuff. But what I want to do is just kind of show you what I'm talking about here. So we have a graph. I didn't draw the coordinate plane. I don't think we need it. But you have, you have your x values. And again, of course, let's just, for the sake of argument here, let's just say that this is our coordinate plane, right? So that's a line in the coordinate plane. All right, so what I'm trying to get y'all to see, or what I want you to understand is, if you think about this x value, right? You think about this x value being 3, and this x value being -2, and the difference between them is 5, right? It's 1, 2, 3, 4, 5. Okay, that being 5. The other way I can think about that is this right here is x2 minus x1. That's the length of this line. Okay? And the height works the same way. It's 1, 2, 3, 4, 5, 6, 7. Right? Okay? It's also, though, y2 minus y1. Or at least the absolute value of y2 minus y1. Okay? So the idea here, the part that I want to kind of get across to y'all is that this vertical height, right, which is the leg, and the horizontal length, which is the leg, would help us do our right triangle to find the hypotenuse, which is also the distance from point 1, so from A to B, right? We can use that vertical change and that horizontal change. So what does that actually look like? Well, it says A squared plus B squared equals C squared, or leg squared plus leg squared equals hypotenuse squared. But I would go back and argue that, well, if you think about it, we just talked about how to rewrite these. So really what we're saying here is x2 minus x1 squared plus y2 minus y1 squared equals the distance of the hypotenuse squared. Well, if I want to solve that for distance, I can take the square root of it. So I can take the square root of all that. And what that leads you to is this. Distance equals x2 minus x1 squared plus y2 minus y1 squared. If you look on your formula sheet, or if you look in your notes, that is the distance formula. So that's the distance of any line given 2 points. So if you're given 2 points in the coordinate plane and there is a straight linear function between those 2 points, you can calculate the length of that line, the distance, by very simply plugging in those points into that specific formula. This one right here, the distance formula. Okay? But it directly comes from the Pythagorean theorem. Okay? The next video will contain all the examples from this unit and talk about parallel and perpendicular and negative reciprocals and same slopes. So make sure you check out those too. But I really wanted to give you an idea of where this distance formula comes from and how the algebra of solving an equation for a given variable, rearranging formulas that we previously talked about, we still struggle with, it applies to things that we are still currently doing. Okay, so take your time, watch this, and go through the notes. This should help you with your problems. Okay.